Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to continue our discussion on how we can categorize map projections by talking about another big piece here, which is going to be called aspect. Right. So in the previous video, we mentioned that we could change the shape of the developable surface, and we went over the three most common: planar, cylindrical, and conic. And we said that the way that we shaped the developable surface was going to have a major impact on the result because of the relationship between the projection source, the reference globe, and the developable surface being changed depending on the shape that we made out of the developable surface. Well, there's another thing that we can do with the developable surface, and that's we can change where the developable surface is located relative to the reference globe, right? Or put another way, we can change the orientation of the developable surface relative to the reference globe. And when we change the orientation, we call that aspect. Right, so aspect is the orientation of the developable surface relative to the reference globe. Okay. And so what I want to do for the case of cylinder, because that's going to be the one that I think is going to be the easiest to visualize, is I want to cover sort of key terms and what those key terms mean. So if we think again about our reference globe, and again, we're going to cover sort of three common terms you'll see here. Right. So the first term you will often see is where you have the orientation, right, of the developable surface running right north-south like this. Okay. Right. If you think about what this does, right, this focuses most heavily on, or is most accurate for, right, this orange line is the equator, right? Hopefully I haven't done anything too crazy here. I've just added in our reference line here, the equator, right? And so when we have the developable surface as a cylinder heading north, oriented north-south, or if in the case of a planar, if the plane is sitting on the equator, right, we tend to call this orientation equatorial, right, because it's targeted on the equator. Okay. So let's then instead say, imagine that we rotated this, right, 90 degrees. So instead of it being oriented north-south, right, instead we sort of lay the toilet paper roll on its side, so that instead it looks something like this, right? Now, right, again, this is our equator. We haven't changed the orientation of the reference globe. We've just rotated the developable surface, right? We've changed the orientation of the developable surface relative to the reference globe. Right. Well, now what happened is, instead of focusing on the equator, what we've done is we've focused on, let's call the meridian. right? A good example of a meridian is the prime meridian, but it doesn't have to be the prime meridian, right? We can imagine that we could spin this in a circle to target any meridian that we would like. But now, right, instead of the orientation best capturing the east-west line at the equator, now what we've done is we've captured this north-south line along a meridian. What we call this transverse. Right? And one of the biggest map projections that we're going to spend time talking about, and one of the most widely used projections on the face of the Earth, is called the Universal Transverse Mercator, right, or UTM. Right, not important now, right, but we will spend a lot of time in a separate video talking about UTM. This is what UTM is talking about. The transverse Mercator part is saying that we've taken a cylindrical projection, tilted at 90 degrees, so that now we're lining this transverse Mercator up with a meridian. Okay? So the final option is to, instead of having it line up exactly north-south or exactly east-west, what we can do is, you can imagine, I'm going to do my best to draw this, is that we pick some other angle right, other than up and down or on its side, right? So this is anything else. This is any other orientation. Okay, right? And what we call any other orientation, right? Again, just for reference, let's throw the equator back up here so you can see we're not changing the orientation of the reference globe at all, right? We still have our meridian and our equator here. We haven't changed the orientation of the Earth. We simply rotated the developable surface, right? Any other orientation, we call this oblique, right? So whenever you see transverse, it means that we've tilted it on its side. Whenever you see oblique, it means that we've kind of done anything else. And then if you see equatorial, you'll see that generally means that what we're doing is we're focusing on the equator. Generally speaking, that means the developable surface is oriented north-south. I do want to cover one additional term that you will often see. And this has to do with conic and stereographic or planar projections. And that is when you have a projection that is focused on the poles. So I'm going to go ahead and use a planar projection in this case. Right? If a projection is targeted on the pole specifically, you will sometimes see this called a polar projection. Right? Typically, you're going to see one of these four terminologies being used. It's either focusing on the equator, it's focusing on a meridian with the transverse case, it's focusing anywhere else in the oblique case, or it's focusing on a polar in the polar case. And again, right, the idea here is called aspect, right? That we can change the orientation of the developable surface relative to the reference globe to be able to highlight, again, the relationship between the projection source, the reference globe, and the developable surface. Hopefully that makes sense. And as always, if you have any questions, please reach out. Thank you.